Okay, chapter 9 is your phrase diagram. So you know that how we set the question already. You set based on this one. Okay, so test one, question 1, question 2 already asked you. But this one will be final exam question 1, question 2, question 3, question 4. And this one question 5 also. So you'll have 4 and 5 for CL4. Who say? That is Dr. Zuraida, not me. Yes. That is for her subject. Right. So your test 2, question 1 will be phrase diagram. Question 2 will be polymer, ceramic, and composite. Okay. All right. Now I go very, very slowly this chapter because we have a loss of graph to understand. Okay. The first one is called solubility. Solubility, you know that when you mix salt into water, you will try to dissolve. Okay. Now this graph is on the syrup and water. Means you put in the sugar, right? The sugar. So there is a maximum solubility at a certain percentage. So on the graph, how you read this graph? Y-axis is the temperature in Celsius. X-axis is composition percentage, W%. So again, if you don't understand what is weight percentage, go to chapter 3 or chapter 4, right? Go and find how you calculate this one. So on the x-axis, try not to make mistakes and not confuse yourself. It will tell you sugar and water. Sugar 0%. So as you move towards right, your sugar content increase. Not for water. Water is start with 100%. As you move towards right, water decrease. It means on this point, you have 100% water, 0% sugar. As you move forward, the maximum you have 100% sugar, 0% water. Yeah. So this is the two combination. The value you add up always 100%. Okay, if you have two component. Now, on the graph itself, you will sure have a state or there's a line called solubility limit. So solubility limit, it tell you correspondent to the intersect at a certain time. So for example, liquid solution, syrup. So syrup, you know, is sugar, right? So in this region or at this temperature, in this region, when you mix with water, no matter how much you mix with water, up to 40% of water is still as liquid solution or syrup. Up to this stage is solubility limit. Then you add more water, it becomes liquid solution plus solid sugar. So you have these two states. Okay. So how to read this graph? This is sugar. Of course, in test, I won't ask you sugar. I'll ask you metals. Right. So in this case, we start with the first point. Temperature 20 degrees C. You go. Our interest is in the solubility. You go temperature, go touch the red line, go down. You will see there's a number there. This number, it will tell you maximum solubility of sugar in water is 65%. Solubility of sugar in water is 65%. Don't confuse with water. Water is 35%. Sugar is 65%. So don't confuse between these two. So we will start to use the solute and solvent. Don't confuse between solute and solvent. Okay, in this case, Water can be solute, also can be solvent. You just need to see which one is your focus. Okay. So at 20 degrees C, if the system is in equilibrium, the composition of the syrup will be 65% dash 35% water. So this is the first equation you derive from the graph. When you see equilibrium, you need to write item A, how many percent, item B, how many percent. In this case, 65% WT percent and 35% B. These two you add up must be 100% WT percent. Okay, this is how you tell or answer the question. In this case, we use sugar and syrup as the starting point. Okay, we go another one. Now we go into state. This one we recall what you learned in your chemical or chemistry. So you have three states: liquid, solid, and gas. Okay, so when we go, let's say we take water. Water, you start with liquid normally. Then if you increase the temperature, it becomes gas. You reduce temperature, get back to liquid. You further use the temperature, becomes solid. And from solid, you increase temperature, it go back to liquid. This phrase or state changing is same in metal. It's only what temperature only. At what temperature, it change. So we'll use phase diagram to explain the behavior of metals. Okay, so the first one is phase. So in the question in chapter 9, you need to tell what is the phase of that element in the certain temperature. Okay. So if at that particular time, you only see one phase or single phase, for example, if you're standing here, you only see gases, then we call it homogeneous. Okay, the system is homogeneous at that particular temperature. If it's ice, or everything is ice, then it's homogeneous system. If everything is water or liquid, then it's homogeneous. This one also homogeneous. Only the transition will be mixing of water and gas, or gas with the ice cube, for example. Okay. Okay. So homogeneous and heterogeneous. These two don't confuse. Homo means same, right? Hetero means different. Okay, just now we see syrup. Now we go into a more familiar item. It's called water. Of course, we won't use water in our test. We'll use metals, but we try to build the understanding first by using very simple material. So you know that water have three phases: gas, solid, gas, liquid, and gas. Gas, liquid, and solid. Your three phases. So you have presence of H2O here versus temperature. So if you read the line, important is the line. So the one that over here, if temperature below 0, you know that this one you will see solid ice cube. And if you increase temperature, solid will melt. It will either become liquid or vapor. It depends on the presence of H2O. Depends on the condition, liquid or vapor. So there will be one point called triple point. What I mean by triple point? Triple point is the heterogeneous system, where at this point, three phases appear at the same time. Means it can jump from, you say it's a liquid, also correct. You say as a gas, also correct. You say it as a solid, also correct, because these three states appeared in triple point. Okay, so this one also apply in metal later on. So there's a triple point in the phase diagram later. Okay, then this one, between solid and liquid, there is a freezing line. Between liquid and vapor, there's a vaporization line. So also have these two in the metal later on. Okay, so if is all these lines are most towards either solid or vapor. Okay, either is solid or vapor. Okay. So, however, all these are depends on the pressure. If it's water, so you pressure versus temperature, right? So if you change the pressure, you change the temperature, it will behave in a certain state. This one you learn in your chemistry for water. Okay. Okay. So this one you read. So this one is single phase diagram. Single phase diagram, or in your chemistry, we'll call it PT diagram, pressure temperature diagram. PT diagram, pressure versus time versus temperature. PT diagram. Okay. So the rest is we already explained what does the line means and so on. Okay. So the line here is two phases equilibrium line. Means if you walk on the blue line here, you can either seeing liquid or a vapor in this line. And if you're walking in this line, you either seeing solid or liquid in this line. Okay, so you are seeing two phases. Okay, so this one is single phases, this one two phases, this one three phases. This is triple line, triple point. Okay, okay. Now we start go into metal. So combined with the syrup and water understanding, we go into ion. So we are using PT diagram, but however, the axis flip already. Just now, the pressure is on the left. Now, the pressure is below. And y-axis become temperature. This also called PT diagram, but the diagram flip the axis already. Okay, most of the time you see this kind of setup. Okay. Now, when you see this kind of diagram, the first thing is where is the triple point? You should able to understand. First thing you identify is where is my triple point. So in this case, you have 1, 2, 3. Okay. In exam, we will remove all this wording. Triple point is where you see there's an intersection of line. For example, this one. You see this line, and this line. So there are 3 lines there intersect. It's a junction. Every time you see a junction, there's a triple point. It's a junction. So here also same. Black will be given. Okay. So black, it means you see this black, when you walk on this line, you'll see left hand side, right hand side, different material, different state. Like here, if you walk on black color line, you'll see gamma and alpha. Gamma on your left, alpha on your right. So when you walk on this one, it means this one is two phase line. You have two phase or two kind of material on your left or right. Okay, at this temperature. Okay, so as long as you walk inside this zone, it's like a war zone. So if you walk below this line, 910 degrees C, you will see alpha. And the form is BCC. You already know what's BCC, FCC already. So you walk on this line, and then if you increase the temperature, 910 up to 1394, you will see gamma. Okay. However, be careful. This temperature, if you go to different pressure, it can flip to vapor. This one, this region from this empty region here is all vapor. Although you increase the pressure, but you increase the temperature, there's a combination between pressure and temperature. It will give you different state of matter. So here, the one here, over here is vapor. This is liquid. This one, you can say as solid, there is a delta there, BCC. So between 1394 and 1538, there is a delta or ferrum there, BCC form. So if you stick one line here, you draw one line here, let's say you put at 1 atmosphere pressure, one line, and you drop from 1600 degrees C, let's say, you will form a liquid form of a pure ion. You drop the temperature until 1538, you will see liquid and solid start to form inside the liquid. When you walk on this line at 1 atmosphere pressure, you will start to see a small particle inside the liquid already. And that small particles, we call it gamma, not gamma, delta ferrum BCC form. Means here. This space, important is a space, territory. It's a territory. So they are, means crystallize, start to crystallize already. It means it start to form something inside the liquid. Yeah, all this graph is for metal. Only one material only. Okay, so this is for ferrum, and yeah, quite direct lah. So important is that you know that at a certain pressure and temperature, you give you 3 different form. So now for metal, now you cannot simply say it's a solid. Solid, then what? Solid, it can be gamma, it can be BCC, it can be FCC, it can be alpha, BCC, and so on. Okay, so different ferrum will give you different color. So you know ferrum can change from green, orange, and red color. So different of this one, you give you different color of ferrum. So when you burn metals, sometime at a certain temperature, you see different color. You see blue color, red color, then go into another color lah. So this is what you see. Okay. From this graph, you know where is vapor, where is liquid, where is solid. Okay. So this one is very direct. Important that you know that at a certain pressure, temperature, what state you have. What state and what is in your hand, or what do you see if you stand at that position? What do you see? Okay. Now, here at 1 atmospheric pressure, at 910 degrees C, you're actually having 2 solid alpha and gamma ion exist at the same time. Yes, means you standing at this line, you're actually you're seeing this one and this one on your left and right. Okay. So above, on the line, you see 2 phases. Above the temperature, a little bit, in even 1 degree C, you flip to gamma ferrum. Okay. So below, it becomes single phase and so on. Okay. Okay. So there are three triple point on the graph, PT graph. Three different phases coexist or triple point. So like here, you have three triple point. So you should able to write what do you have at the certain triple point. For example, liquid, vapor, and gamma ferrum. Liquid, vapor, and delta ferrum. Where does this point is? Here. Liquid, vapor, delta ferrum. Where's it? Vapor, liquid, delta. These 3 meet together is this point. No, this one. This is the triple point. This one. When you stand here, what do you see? It's like left, you see vapor. Front of you, you see solid. Front of you see what? Delta. Then below on the left, you see gamma. No liquid. Yeah. So it becomes this one. Second point. Third point is here. Third point means you see vapor, you see gamma and alpha. You stand here. Second one don't have. Second one is you see these 3 things: vapor, delta, and gamma. You stand here, you see what's surrounding you. Here also, what's surrounding you. Okay. Okay. Okay, this is phase diagram of a pure substance. Then we go into another diagram called Gibbs phase rules, phase diagram. Okay, so it's a scientist called Gibbs. Okay, so we're going to introduce you this phase rules called P plus F equal to C plus 2. What is P? P is number of phases. So you only have 3 phases. Either it's liquid, solid, and gas. You only have three phases. Number of component in the system means how many item you have. For example, just now the metal you only have 1 in pure metals. But just now in the water syrup one, you have 2. You have water and syrup. So your C become 2. Okay. F is a degree of freedom. Degree of freedom means how many form that it can change. It depends on pressure and temperature. At a certain pressure, it gives you certain freedom. So by applying F plus P plus F plus C, so let's say we take water. Let's say we take water scenario. So water scenario, okay, at triple point here, 3 phases coexist at the equilibrium. So P is 3. Number of component, 1, because it's only water. So what is the degree of freedom if you complete the equation there? What is your F? 0. Means at triple point here, 0 freedom. Means 0 freedom means you already seeing the 3 phase. Means no, freedom means how can it change form or not? Can it change form to other? Triple point cannot. It already have the 3 form already. Cannot change already. I only have 3 . So at triple point, no freedom. Means it's already have all the complete there already. The complete state there already. So no freedom. Okay. 0 degree of freedom. This is how the chemistry works. Okay. So if you move at the liquid solid freezing curve, where is the liquid solid freezing curve? This one. Okay. So here, if you do the same procedure, how many freedom you have? Along this line, how many F? 1. Okay. P is 2. Phase is solid. So 2. C is 1. You only have 1 water here. So your freedom is 1. Meaning along this line, it can either change to liquid or solid. You can flip between these two. Oh, sorry. Degree of freedom is the parameter that you can play. Sorry. Okay. Sorry. Okay. Means on the graph here, you can play with pressure and temperature. Okay, correction. It's not the phrase. It's the parameter that you can play. So for example, triple point. It fixed at that point already. It fixed at 1 pressure, 1 temperature. You cannot change the pressure or temperature. You change a little bit, it will shift to another side. Understand? So correction. Degree of freedom, F here is the parameter that you can play on the graph. So here, triple point 0, because you cannot change temperature, you cannot change pressure. Fixed already at 1 point. So at the line here, you have 1 freedom, meaning you can either play with pressure or you can either play with temperature. Now, for example, if you walk at this line, you want to change, you want to change to solid, how? Either you change temperature or change. In this line, almost is pressure almost constant. no, the temperature almost constant, you change the pressure lor. Okay, let's say you pick one line here, then you shift to the left, you change the temperature, it becomes solid already. Sorry, you change the temperature, become uh, so it means you draw a line, you see whether what can you change. So you draw one line, you fix the pressure, you can play with temperature. You fix the temperature, you can play with the pressure, but pressure not very significant lah. You can play until very high lah. Okay. So this the concept is Gibbs phase rules. P plus F equal to C plus 2. So this basically is the first part of the question for test 2. Very simple to score. They ask you how many freedom. I mean, they ask you how many freedom. Of course, not water lah. Okay. Okay. So degree of freedom actually is a parameter that you see on the graph. All right. Okay. 3. 2. But later you will see 1 is 3 1. Okay. Okay. So and the rest you read. Okay. The rest. Yeah. Correct. So if a single phrase one, the degree of freedom is 2. Single phase one, liquid, you want to change to solid or vapor, you can change temperature or pressure. Okay, so once you understand this one, then you call okay. This one is for single degree. For one phrase diagram, this one, P plus F equal to C plus 2. This one apply for single material. For example, water, single component or means single material. Means pure, like for example, water. I mean, on the graph only tell you water. Syrup cannot, syrup graph cannot use this formula. Like what? It have to be one item. Like for example, water or pure iron just now. Okay. Okay. Plus 2 is the formula of for that one. They derive from the experiment one. Okay. Your job is to memorize that this one plus 2. Then for binary, no, binary plus 1. Binary means the syrup one, water and sugar. Material. Means under here you will see something different. 0 to 100, 100 to 0. You will see that one. Okay, so again, I need to highlight this one. Don't confuse between the top and bottom. Plus 2 1 is individual or single phrase diagram. P plus F equal to C plus 1. This one is binary phrase diagram. Okay. Now, in pure metals, in pure metal, again, you see 3 phases. You look at the graph here, is temperature versus time. The axis change already. Now it's temperature versus time. So when you drop the temperature, you will see liquid. At a certain temperature, you will see liquid plus solid and then solid. Okay, so gas will be here. You freeze the temperature, how you see gases in pure metal cannot. Metal should be higher, so this is vapor, but it's rarely see metal in vapor unless very hot. Okay, so you pour and then temperature and so on. So what is important is the changing phases. For example, A to B. A to B is cooling of the liquid. Then B to C, B is solidification begin, means you start to see something grow inside the liquid already. Okay. Then C, here is solidification end and start to cool. Okay. Okay. B to C is start to, okay, this B point, you start to see small dot, like particles start to grow already, like start to grow ice already. Got small chicken pox like that. Then as it move from B to C, the chicken pox grow. Ice cube, it grow. Then when you reach C, 100% ice cube already. Like it become a solid lah, not ice cube lah. 100% solid, but it's still warm. It still have temperature. Understand? Then after C, 100% solid already, it cool down. The whole metal cool down. Okay, right. So this one is self-explainable lah. You go and read lah. Okay, because you won't see this one in your test. Okay, another one is this one is the transformation, solid state transformation. Okay, temperature versus time also. So the first one is liquid. This one you need to memorize a little bit lah. Like metal, you start from liquid, you cool down. The first one you get is gamma, not gamma, delta. You cool down, you get gamma. You cool down, you get alpha. One is color, another one is the crystal structure. Just now you see BCC, all this BCC, FCC, and so on. But logically, you should able to understand when you cool down liquid, it will come from liquid, then go to delta, then go to gamma, then go to alpha. You should follow this phrase lah. This kind of logic, when you reduce the temperature, delta, gamma, alpha is like a step lah. Okay, right. So when you do exercise for your assessment like test 2 or final exam, when you see the temperature of alpha higher than the delta, means something wrong already. Means something wrong because you will see delta more hotter than alpha in the normal setting. So this is like a self-check lah. Like you're seeing gravity 9.81. If you see gravity 8 point something, means something wrong. Like this lah. The concept is like the logic is there lah. So there are delta, gamma, then go to alpha. Okay, this one you see lah. The delta will be BCC structure, and so on. Okay, so we'll start to see on a molecular level. So now we look into binary system. Binary means two different material. This morning we learned about strengthening mechanism. You mix impurity inside. So there are two mechanisms. One is substitution, one is interstitial. Means this one you replace, but must follow the Ohm's law, RH law, right? The size must be within 15% and so on, right? Go and read now. What is the RH law? Go and read now. It's important. Okay. So they are either this method or this method. Both also make the material stronger. Okay. So substitutional or interstitial, these two will give you binary system, binary metallic system. Okay. Okay. This system only a single type of crystal structure exists for all composition. They are called isomorphosis system. Yeah. So if you're having an isomorphosis, it's actually a very easy question because everything have the same crystal structure. So if you see BCC, then BCC. Okay. Again, Ohm's rules, I repeat here again, is important. The 9, another chapter. So for strengthening metal and chapter 9 is important. What is Ohm's law? What is Ohm's rotary law or HR law. First, the size must be within 15%. Second, element should not form compound, means it cannot have a chemical reaction because of the electronegativity. Like family 1 will usually try to find family 7 to form stable element. So it cannot be there. It must form the same family. Okay. Crystal structure must be the same because when they like do the the drill, the arrangement, if you have the same crystal structure, then very fast. They'll align themselves very fast. So very important, this one, for binary isomorphous alloy system. Okay, number 4, same valence. Same valence means same family lah. Right? Family number 1, you have only one electron outside and so on. Okay, so that they must be the same. If not same, then become we disagree with law number 2. If it's not same variance, then it will form compound already. Okay. Okay, first real metal, very popular. This is copper nickel diagram. No need to memorize, but you should able to understand or find the correct graph. You will see more than 3 kind of graph. Same shape but different axis, different temperature, different material. Okay, so the first you look at phase diagram is the y-axis temperature. Your x-axis will be the weight percent axis. Here, right hand side it tells you nickel. So at this point, how many percent copper you have? Good. This one, 100% nickel. So as you move towards right, the more nickel you have. This is binary system. So you should able, let's say I pinpoint A. I pinpoint A point. What is the formula of the composition? What is the composition? What is the binary system for A point? Like this one. Copper 80. So you should able to write 80% WT%, Cu 20% a dash, 20% WT and I. Very easy one. If you understand binary, if you understand phase diagram, it's easy lah. If you don't understand, then it become difficult lah. Freedom means you use the +1. Okay. Okay. But basically, you just read the graph, right? Just read the graph. So y-axis, x-axis, but the challenging part is the x-axis. Sometimes you will confuse which one is which one. Okay, when you panic, you read copper one. Normally, my practice, I always go to the end and see what is my focus. But because normally this kind of graph got two elements. So to avoid I confuse, because here you see 0 and 100%. You will confuse either this is copper or nickel. So I always like, okay, I look at this one and I look at the end. Most of the time you see, it will also give you hints already. The influence element actually is nickel. Right? So weight percentage of nickel. So the more you move to the right is the one that you see on the topic here. So 100%. Okay, so once you understand the axis, you should able to look at the phase that you have. You have liquid, you have solid. How many solid you have here? How many type of solid you have here? How many type of, just now solid you see alpha, gamma, delta, right? So how many solid you have? How come you have 4? How many type of solid? How many solid you have? One. What is that? No. What? Alpha. You only have alpha. One. One type of solid. This is all solid. Copper in alpha solution. That means it's a solid lah. Okay, sorry. Let me see. Sorry, it's a solid. Solution is alpha. Sorry, solution is alpha. So it's a solid lah. Means in the middle here, you already tell you already ma, L plus alpha. So here you got two phrase, two state there. Liquid plus this one. Alpha is a solid lah. Means the copper alpha. So we got two type of one is liquid, one is solid. Here at this region, these boundaries. Okay. Then on the line here, what the blue line means, it means two phrases, equilibrium state. This line, it can mean is not one, it means two phrases or two phrases can coexist. Yeah, because you're walking on the line. So like you're seeing left or right, you're seeing liquid or liquid plus alpha. Yeah, means if you walk on this line, the left hand side you'll see liquid, right hand side you'll see liquid plus alpha. So on the line here, what does it mean? What mean by alpha? What mean by solid? If you walk on this line, what is the shape of the solid that you see? You see very small, right? Can you imagine? Like this, if you walk on this here, you still, because it start to form solid already, but you still have liquid. So on the line here, actually you see very small particles, small chicken pox. Then as you move in, liquid reduce, all the liquid will form chicken pox, like it will form like ice cube. Can you imagine? So okay, if I pull this one out, so if I use diagram, liquid I can no need to draw lah. But here, if I scoop something from this line, I will see liquid plus small dot. This small dot is your alpha. Then as you move down, let's say you reduce your temperature. Let's say I draw a straight line. Let's say I stay my concentration at 70% of nickel. I fix my concentration and I drop from this point to this point here. So my chicken pox will grow. I have liquid, but it will be bigger. The location, the chicken pox still same, but bigger. Yes. What happens if you reach this line? You still see liquid, but the size of the chicken pox is bigger. Once it's past this line, all solid already. Means how you draw solid? You draw scale, like your fish scale. All these are alpha. No more liquid. No, got space. No more space lah. But no, don't write liquid inside here. Means this all solid. Don't need. It depends lah. If the question want to give you marks, then you will ask you to draw now. It will ask you to calculate how many percent liquid you have, how many percent chicken pox you have. Okay. But draw cannot. We are all learn engineering so we need numbers. Okay. So if you understand what we discussed just now, the rest is on the slide lah. Okay. Okay. So you see, if we enlarge the same graph, this is a copper nickel phase diagram. So you have copper and nickel. So can you find area above the, okay. So you know liquid lah, liquid. So stable, the liquid stable here. The rest is solid, or you can use solidus or solid, it's the same. Liquidus, solidus, and liquid and solidus. Okay. Before we go home today, we need to learn what is grip phrase rules. Grip phrase rules, again, we are using +1. Why we're using +1? Because this is binary system. We call it binary system or two component. Right. So at melting point of the pure component, where is the melting point? Yeah, enlarge the where? Where is the where or from this graph, what is the melting temperature? Yeah, from the one that you see on the 1300. 130 here liquid. All here are liquid. This one. This one is the lowest melting temperature it can go. Highest is 1455 at 100% nickel. At different concentration, different melting temperature. So when I ask you question, you have this specific, like what is the concentration? You cannot say 1008. 1008 is 100% copper. This is copper melting temperature. Because it's 100% copper. Then the question will be stupid question. They ask you like, what is the melting temperature for nickel? You read from this graph. Melting temperature is 1455. Understand? 50%, 50-50. 50-50 is here. Here. You need to project to here. Understand? 50% means 50. If you are looking at 50% copper, 50% nickel, means you draw the line above this line. This line is 50-50. So you up, touch this line. Touch this line. The top already liquid already. You want to see what is the melting point. What I mean by melting point? You don't have solid inside the container. So the more you move up is no more chicken pox. You want to eliminate zero chicken pox. So you go up. This is the point. So move to the left is the temperature for 50-50 concentration. Okay, that is how you explain. Yeah. Okay. Okay. So again, this is just to show you how to use a freedom equation. Okay. So if your degree of freedom is 0, it's called invariant point. Right? Means you're not able to change any parameter. Right? Number of components is 2 in this graph. One is on the pure component. If you only want to look at what is the melting temperature for copper, it's 100% copper, only one. So your cannot be 1 already. If you move from here, then here also 1. But here cannot be 1. Here is 2. Within 0 and 100 is 1. Okay. So melting temperature, your degree of freedom is 0. That means there's exact temperature and pressure. Here don't have pressure, but in this case, you already fix your 100%. So you cannot change temperature already. So only one point that appeared as a liquid. Okay. Okay, the rest is single phase and so on. So you can calculate lah. This is how you calculate the things. For A just now, 20%. This one you have 100% solid alpha. For example, A here at this temperature, you will have 100%. And so on. So this one you read the slides. Okay, so if we pick one point, like for example, 53% nickel, 53% nickel, 47 copper at 1300 degrees C here. So the composition of liquid phase can be determined by drawing horizontal tie line. So we are teaching you a method to calculate at this point how many percent liquid you have, how many solid you have. Okay, it's a very easy formula. It's actually finding ratio, L and solid, or you can say A and B. You have a total, right? Total is A plus B. So you want to find ratio of A. So A divided by A plus B. Okay, but there's a trick there. So the trick is that if you're finding somewhere here, you're actually using another side. Yeah, I show you. What does it mean? Okay. Okay, this one is just another presentation. This one is a pure metals. If you drop temperature, pure temperature, it will drop. This is cooling temperature to solid. So at a certain temperature, it will cool from liquid to solid. This one is quite direct. Okay, so I want to show you the methods. We'll use L and S. This one you read. This one you read. We'll now teach you what is level rules. Level rules is actually we're using the ratio. The ratio of here to here and here to here. You need to find three point. So the first step for this one is to find the question. What is the percentage from the question? You go and find percentage of that. For example, 50-50, you go and find 50 here. Lock the position. You move up, draw a line of your x. X means the question want to ask you one. You draw one line from the composition. Once you draw one line, the question will give you one temperature. You move one temperature, use your ruler, draw another line. You're making a cross. Okay, you're making a cross. It means that when you cross, you'll be touching the blue line. This blue line is what? Liquid, right? Liquid and solid. Right? If you walk on the top blue line here, you'll be seeing liquid and solid. So here, this dot is liquid form. Makes sense, huh? So as you move towards right, your liquid will grow, become more and more solid. Here becomes solid. This point is solid. So you have L, O, and S point. L, liquid. This one is solid. This one is L, O. The formula for level rules will be, okay, this is called tie line. It's called tie line. So on your graph or in your answer, we expect you to draw this three line with the time, and then you write LOS in your diagram. Usually you need to detach one. You just do your working on the graph that you see in the appendix. Okay. So the first one, you draw the X, then you draw the tie line, then you use the fraction of that one. So I'll give you the fraction. So you know that level rules, liquid plus solid must be 100%. Okay, liquid percentage plus solid percentage must be 100%. So the percentage is 1. I mean, the full number is 1. right? The ratio lah, the ratio. So how do you find the fraction? The fraction of liquid is 1 minus the solid, right? Makes sense or not? So if the combination of liquid plus solid, you get 100%. You want to find liquid, what do? You take 100% minus the solid one. Makes sense, huh? Okay. Or once you find this one, you just take 1 minus this one. Same. It's the same thing. Okay. So let's say we put 1 gram of alloy. If we have 1 gram of alloy by using this diagram. So 1 gram of alloy, and we make this as a weight balance. Gram of B in two-phase mixture equal grams of B in liquid phase plus solid phase. Makes sense, huh? So in 1 gram, we have certain gram of B in liquid plus certain gram in solid. So what we do? We take 1 gram, multiply by 1, and the percentage of the weight. Plus, so this is weight percentage lah, weight percentage. Okay, so this is average weight fraction. Average weight fraction. So here, if it's liquid, we multiply the liquid fraction by the gram. Same with this one. With the solid, this one. Okay. So if you simplify your gram, the weight of your solution equal of the fraction of your liquid plus the weight of the liquid plus the solid plus the weight of the solid. Okay. So we don't want to have so many unknown parameter. We convert our liquid in terms of solid form. This one, we take this one, substitute here. Then we can bracket, become this one. Okay. So you simplify the equation. Rearrange. Okay. Makes sense, huh? This one you move here, this one you move there. Okay. Okay. So you rearrange everything, you'll get weight of fraction in solid phase will be WO minus WL divided by WS minus WL. Okay. To find the liquid, you take 100% minus this one. Let's say this one you get 40%. Liquid will be 60%. What you need to only find one. Another one is you take 100% minus that. Okay, it's the same, huh? Okay, so actually it's the same, but is any you can memorize this one or memorize this one, is the same. Okay, so this is called level rules. Okay, this is called level rules. I will show you how to do. It's called level rules. Level rules. Why level? Because this line. Okay, derive level rules. This one. Okay. We have temperature. This one, component A, component B. This is a binary system. So as you move forward, you have more B. Okay. So again, you see the shape of the graph change already. Just now it's this, like this. This, but the method still the same. You draw the first one, you draw the target weight with its X, you label as X, then you target weight, target percentage lah. Then you follow the temperature instead in the question. You draw one line. You do the time line. After time line, you will see you need to identify whether this is liquid or solid. This is solid. But if I flip the graph, it become different already. Left hand side, not necessarily all solid. You have to be smart enough to differentiate. So this one, it tell you liquid already. So this far right point is liquid, not solid. This one is solid. So this one is S. So your LOS flip to the previous one. Okay, so you do homework, you do, you will get this one. You refer to the slides, you derive the equation. Okay. This one, very high chance will be, yes. I mean, the slide already show you another shape. This one, I flip the shape. Very high chance will be in final exam. Test 2, I test you other thing. Like your test 1 things lah. Okay, we go through this one, then we call it a day. So we apply what we learned directly on this one, because this one I can test you in test 2. Very easy to test you. Okay. The one that read from the graph one will be in test 2. Okay, so you look at the question give you copper nickel. 47% copper, 53% nickel. My practice, I always go to nickel, reverse back, 53, then I draw X straight away. Okay, so at least I know, like, okay, then maybe I write here 53 to remember this is what the question give me. So I write 53, I draw out, and nickel, write nickel there, right? So it's at 1300 degrees C. Of course, in test, you won't see all these things. Okay, you only see 2 blue line, liquid L plus alpha, solid alpha. Okay. Of course, you won't see copper nickel graph. You will see other material graph. To test whether you understand or not. Okay. So what is the weight percentage of copper in liquid and solid state at this temperature? Same. You draw a line from 1300 degrees C, because the question asks you focus. First, you draw the X first. The X is 53. So from here, you go and find your X. You draw one X line. Roughly 53 . But in exam, it will be it will give you a full number that you can draw straight. Okay. So in this case, 53, you draw one X. Then you follow the temperature. You draw another one. You draw you want to use the level rules. So level rule, you need to draw the tie, the tie line. You need to draw the cross. Okay. So this one you draw. This one you draw. Then you see the level rules already. The 3 point. Okay. This one is liquid or solid? Liquid. This one O. This one S. LOS. Okay. Okay. So no need. Read from the graph. You write the equation. You write the equation. No need. You just need to find what is the length of this one, what is the length of this one. Okay. Like this formula. You only need to calculate the ratio. I show you this example. So the intersect of 1000 degrees C tie line with the liquid give 55% copper in liquid form. It means the question might ask you, what is the 100% liquid at 1000 degrees C? What is the percentage of composition? You draw this one, mid here. This line is all solid, liquid, right? So what is the percentage, or what is the composition with 100% liquid? Move down here. You will see 1% here. Here is about liquid copper correct, copper. Percent nickel, right? So both same, but it's safe to write 2 component, 55% copper plus dash 45% nickel. Okay, so at this point, it's all liquid. Okay, then intersection point give you this one is all solid, which is about 50 something lah, 58% nickel. But you cannot only write 58 lah, write 42% copper dash 58 nickel. Okay. Okay. Okay, because why? He asks you copper. The question asks you copper. So you focus on the copper percentage. But my practice is I always like to write 2. Then I choose what question want to ask me. For example, the question asks me copper. But I always practice like I see the one on the right hand side one. So I always write 2 and then I read back the question, in this case copper. So I read the copper percentage. Okay. Right. So since we have the percentage of the things, so here is WO is 53% nickel, means the question WO is here, your LOS ma. O is 53%. S is where? Here, right? Solid ma. So it's here, 58%. So 45% is the liquid. So you have 3 number here. So the question give you ma. Okay. So the only trick is you memorize the way you calculate. This one, actually I don't memorize this one, but you for your test, you need to write like this. Okay. So I memorize the way to calculate. The top one is LO minus L. Okay, this one. How you calculate the top value for solid phase? Okay. Okay. My trick is here. Let's say this is liquid, O, this is S. This is A and B length. If the question asks me solid, how many percent solid? I will length divided by A plus B. If the question asks me solid, another side. So I will read the one opposite the side. If the question asks me liquid, I will use B length opposite. So that is how I memorize lah. So if you see the working, if the question asks you solid, you move to liquid. You calculate liquid length. Here got liquid solid ma. I mean, you see it as A and B lah. So the more you move to the left is liquid ma. But the question asks you solid, right? So yeah, the difference of percentage. So you take the length of LO lah. LO. So this one is you take 53 minus 45 is the distance of this length divided by total length. Total length is 58 minus 45. So you take that one, you get 0.62% of solid. Means at this temperature, at this point, I have 62% of solid. From here, you know your liquid already actually. 1 minus that one. Yeah, 1 minus this number. Same answer. Because it's a pair, it come by pair. Come by pair. You want to use the percentage of copper also can. Our working here, we are using nickel. Okay. Why nickel? Because we are more familiar with the 0 to 100 system rather than from 100 to 0. So that's why I very focused to the right hand side parameter. Okay. So your answer for this one, the A, For B will be weight percentage of solid phase equal to 0.6 times 100%. You convert the fraction into percentage. Okay. Then the liquid phase, if you want to do calculation, also can. But if you write 1 minus 0.6 something, also get the correct answer. No, same marks. Same marks. You want to prove this one also can, but you don't need lah. You find one solid, you just minus 100% minus that one, because this total line is 100%. Okay, that is a trick lah. So the careless mistake is you don't understand where is your L, where is your O. I mean, if you change the shape of the graph already, you confused, like where is solid, where is liquid. You read from the graph. You read from the graph. This one, right? This one. No. I mean this one. You will see this one. You're given. Some of you panic, because this is very easy. Later you'll see another one, not like this one. Okay. Like this. That's an L. But you should be able to do the same, right? Yeah. So the question give you, if you repeat the same step, you see, percentage of liquid and solid for AG, PD, and at 1200 degrees C. So straight away, go and find 120 degrees C. Yeah. So here, you just draw one line. Then you go and see the question give you 70% AG. So AG 100% here. So go and find 70%. Draw one line. So you already have the revolutes already. So one line costs you 1 mark. So one mark. Then you go and label LOS 1 mark. Where is your L? Where is O? Where is your S? Then 1 mark, 3 mark already for line. This one, it depends lah. If test, it can be 1 question, 35. I try to mark up lah. I mean, if this one. Yeah. Okay. So, of course, normally for test 1, you see 2 graph or at least 2 graph. So 1 graph is about 10, 12 or 13 marks. 2 graph lah. Means 1 question you have A and B, different graph, to prove whether you really understand the things. Okay, so you have the percentage, assume liquid phase. This one reverse. It tell you assume AG in liquid phase have 74%, and solid phase is 64%. It means you drop this one down. This one is 64. This one is 64. This one's 74. So you have the total length already. So the one is O. You know your O, your O is 70%. So it's very easy concept. You have 3 points already, very easy already. This graph is LOS. Then you have 70, 74, 64. So if you just want to memorize it, very easy. So 1 to 5 percentage of liquid. Take this one. Liquid here, so you use this one. 70 minus 64 and 74 minus 64. So 6 over 10, 0.6%. This one, liquid, or 60%, 0.6 lah. So it will be 60% liquid. Then 40% solid lah. You draw this one by this one. So this one you write percentage of liquid equal to what is 70? 70 is WL . sorry, WO minus WS. And this one is total WS minus WL minus S. Then you substitute value, you prove already. Like this. Very easy one. Very easy one. Now I show you the step. It's a very easy one. Now, one line, 1 mark. Now, this temperature, 1 mark. This X, 1 mark. This 2, 1 mark. 1, 2, 3, 4, 4 mark already. Then label LOS. So you get 60%. Right? This one, LOS. This one 4 mark already.
Line type from the dotted line straight
No
line.
lah, same one. So
Same, okay.
1, 2, 1, 2, 3, 4 lah, 4 marks. Graph 4 marks already. Then this formula, of course, one more formula. So 1, 2, 3, 4. So answer usually is 2 marks. Steps 1 mark, 1 mark. About there lah, 8 about 4 to 5 lah, 4 to 5 lah. 4 to 5. 4 to 5 marks. Yeah, then you find the liquid, then you find for solid. So about 4 lah, 8 marks already. X, this one like 4 marks, so it's about 12 marks. So one question lah. Okay. So the same lah. Either you do calculation or you take 100% minus the previous one. Okay. I think we stop here. Then we continue next week. Okay. Hey, got class replacement on Wednesday.